In this video, I'm going to record combination of functions, composite of functions. So which topics I'm going to cover here? I'm going to cover domain, combination of functions, composite functions, and domain for composite functions. So let's start from the domain. So let's assume we have, so first example, f of x is equal 1 over x minus 3. So, well, we said domain in denominator, domain can be anything, but the case where denominator turn to 0. So which means we have to put for domain x minus 3 cannot be equal 0, x cannot be equal positive 3, right? Okay, so for domain, this is positive 3, right? So it's breaking down into from negative infinity, this is positive infinity, so break down into negative infinity to 3, and then from 3 to positive infinity. In the format of interval, it's going to be from negative infinity to 3, or 3 to positive infinity. If any one of these intervals fall the domain, then it will be accepted, but cannot be accepted if it's 3 in there, correct? All right, next one, f of x. Okay, let me switch the color so you can understand that this is a different example. F of x is equal square root x minus 3. What is going to be here domain? We know one thing, that under square root we cannot have negative number by simple reason that no number squared is going to give you negative, right? Therefore opposite operation like square root cannot have negative number, right? Therefore, what do we gonna put here? That x minus 3 always has to be greater or equal 0, right? Which means x is going to be greater or equal positive 3, correct? Because if it's 3, if it's gonna be less than 3, then we're gonna get negative, right? Under square root. Let's say if I take, let's say I can take 2, for example. 2 minus 3 is negative 1. So there is no square root from negative 1. So at this point, what is gonna be our domain? It's gonna be from 3 to infinity. Why we put 3 next to 3 square brackets? Because we have equal sign. That means 3 also accepted. 3 minus 3 is 0. Square root of 0 is 0. Next one. Let's take next example. F of x is equal x squared plus 3x and minus 17. So we don't have here any division, right? So we don't have to worry, and x can be anything, and we will get the working at any of this f of x will get it working at any value of x. Therefore, the domain is going to be here negative infinity, positive infinity, all numbers. Another one. Let's do it one more. So g of x is equal 5x over x squared minus 49. So obviously x squared minus 49 cannot be equal 0, so we don't have division by 0. And x squared cannot be equal 49, right? and x from here cannot be equal plus or minus 7, right? Because what we do here, we take square root of here, square root of here. Therefore, cannot be equal plus minus 7. This color, red color, came out too thick. It's covering 49, I think. So let me see. Cannot be equal 49. So let me take, okay, square root of x, square root of 49. Very good. So from here, our domain is going to be broken down into between -7, +7, and behind. So which means it's going to be from negative infinity to -7, -7, +7, and from 7 to positive infinity. So the domain is going to be negative infinity, -7, since -7 cannot be. That's why we put parentheses, or negative between -7, +7, or +7, positive infinity. Okay? All right. So next, so moving next to, it's going to be combining function. It's going to be combining functions. So combining functions. All right. So here are the rules of combining functions. The algebra of combining functions. So first one, it's the sum of functions is equal, let me write down, sum of functions is equal function of sum. This is sum for functions. This one I'm writing right now, f of x plus gx. It's a sum of functions is equal function of sum. Okay? Next. Difference. Function of difference is equal difference of functions. Third, function of product is equal product of functions. Oops. And the fourth, quotient of function of quotient is equal quotient of function. Obviously, since here we have quotient division, so we need to make sure that g of x will never be equal 0. Okay. Now we have all these four properties or four algebra operations. So let's solve examples. First one. So let's assume f of x is equal x minus 5. G of x is equal x squared minus 1. So let's do all these operations. First one, we're doing sum, which means f plus g of x is equal f of x, which is x minus 5, plus g of x, which is x squared minus 1, right? Here it is, f of x plus g of x. So this is going to be equal x squared plus x and minus 6. Okay, so domain, what is going to be domain here? Since we don't have any division, domain for this function of sum, it's going to be from negative infinity to positive infinity. Every time when we don't have any division, function is going to be, domain is going to be positive and negative, infinity to positive infinity. Second one, so this is our, let me see, original problem. This and this. So you would know because we are going to do these operations. So this is the first operation. Second one, f minus g of x is equal f of x, which is x minus 5, minus g of x. Since it's minus g of x, I put in parentheses x squared minus 1. Let me put some. Okay. Well, easier to clean and put it back. Okay. So because it's a subtraction, we put in parentheses, which is going to be equal x minus 5, and then will be minus x squared and plus 1. We distribute this negative because it's negative sign. It's going to flip every single sign. And that is going to be equal negative x squared, I'm writing down in descending order, plus x, and then minus 4, these like terms. So we don't have any division. Again, domain is going to be from negative infinity all the way to positive infinity. And again, since negative infinity and positive infinity doesn't have limit, therefore we put parentheses. Next, we do multiplication, product. So f times g of x product is equal f of g, which is x minus 5, times g of x, which is x squared minus 1. So here we're going to do just the regular multiplication, which is x times x squared, which will be x cubed. X times negative 1 will be minus x. and then negative 5 times x, it's going to be negative 5x squared, and negative 5 times negative 1 will be plus 5. So as a result, we have the following: x cubed minus 5x squared minus x plus 5. I just placed in the descending order. So there is no division. Again, domain is going to be negative infinity, positive infinity. And lastly, we will do quotient. Okay. F divided by g of x, it's going to be f of x, which is x minus 5, and divided by g of x, which is x squared minus 1. Okay, that's all, because we can't do any simplification, we can't do anything, so we are done. So the only thing we have to mention that x squared, the domain x squared minus 1 cannot be equal 0, which means x squared cannot be equal 1, and accordingly x cannot be equal plus minus 1. Why plus minus? Because and negative 1 squared and positive 1 squared will give us 1. Therefore, the domain is going to be broken negative 1, positive 1. So from negative infinity, negative 1, from negative 1 to positive 1, from positive 1 to positive infinity. So negative infinity, the negative 1, or negative 1, positive 1, or positive 1 and positive infinity. Okay? So now let's move to composite functions. Composite function. This is what a composite function says. F composite of with g of x is equal f of g of x. And well, for given f of x and g of x, f composite with g of x is equal f of g of x, and g composite of f of x is equal g of f of x. So let's work on this. Let's understand. As you can see, f composite of g or g composite with f, those are two different going to be operations because of, look what we get, different form. Okay, let's see how we're gonna work. For example, we have f of x is equal 5x plus 6, g of x is equal 2x squared minus x minus 1. All right, so f composite with g of x, it's gonna be f of g of x, right? What does that mean? We take function, this entire function g of x, and we are plugging into function f of x. That's what means, because this way f depends not of x, but f depends on g of x. So that's gonna be 5 times, instead of x, I'm plugging the whole this g of x. It's gonna be 2. Let me change the color so you can see what's happening here. So instead of x, I'm plugging 2x squared minus x minus 1, right? And then plus 6. So result from here is distributing this 5, because it's multiplication. It's going to be 10x squared minus 5x minus 5 plus 6. And the answer is 10x squared minus 5x plus 1. So, and this is f of g of x. Okay, now next one, let's take opposite, I'm sorry, not opposite, but G composite, move a little bit down, G composite with f of x, it's going to be equal. Now what's going to happen, this 5x plus 6, I'm going to plug into g of x, which means plugging into this x squared and then plug into this x. So what do we have? 2 times 5x plus 6 squared, because we have here x squared, right? And then minus x, which is minus, okay, let me pick it, minus 5x plus 6 and minus 1. 1 second. And minus and plus minus 1. So what happened is 5x minus 6, this is f of x. We plug into x squared, then we plug into minus x. So we plug the value f of x, we plugged into g of x. Okay? So that is going to be equal twice 5x squared plus 6. I'm applying here formula. Let me refresh your memory. A plus b plus minus b squared is equal a squared plus minus 2ab plus b squared. So here we have 2 times 5x squared, because we have a squared, plus twice ab, my a will be 5x, b will be 6, and plus b squared will be plus 6 squared, and minus 5x minus 6, because we are opening here, we have negative sign here. Okay, so, and minus 1. So equal twice 5x squared is 25x squared plus 2 times 5 is 10, 10 times 6 is 60, so plus 60x, and then 6 squared plus 36 minus 5x, negative 6, negative 7 is minus 7. Now we open here, 2 times 25, it's 50x squared, 2 times 60x, it's going to be plus 120x, and then plus 36, it's going to be 72, minus 5x minus 7. So what do we get from here? G composite with f of x is equal 50x squared plus 115x like terms, and then 72 and negative 7 like terms, plus 65. Okay, so let's assume we want to find this composite f of composite with g of x. Instead of x, let's say we want to take composite with -1. So where is our the f of f composite with g of x? And it's right here where I messed up here. This was f composite of g of x. Sorry. Oh, not this one. No, I did here correct. Hold on, it's upper, higher here. F composite of g of x, here it is. So I'm plugging -1. So it is equal, let me write down. First, let me write down. So we had here 10x squared minus 5x plus 1. Now let's plug 10 times -1 squared minus 5 times -1 and plus 1. So that is going to be 10. -1 times -1 squared is 10. I mean, it's 1. 10 times 1 is 10. Plus 5 and plus 1. So that is equal 16. Which means f composite with g of -1 is equal positive 16. Okay? Another one. Another example. F of x is equal to x minus 1. G of x is equal x plus 3 over 2. So let's find f composite with g of x, and then we find g composite with f of x. Okay? So first one, f composite with g of x is equal. So what do? We plug this g of x, we plug to f of x. So it's going to be twice x plus 3 over 2 and minus hold on, it's supposed to be 3 and minus 3. Okay, so what is going to happen here? 2 times x plus 3 over 2, because 2 we represent as a 2 over 1, so it's going to be 2 times x plus 3, 1 times 2. This 2 and minus 3, this is gone, so we get x plus 3 minus 3, also gone. The answer is x. Okay, next one. G composite with f of x is equal. Now opposite, f of x is going into g of x. Okay, so okay, I guess I can use this color. So what's going to happen? Instead of x, I'm plugging 2x minus 3. And then plus this 3 over 2. That is equal. -3 plus 3 is gone. 2x over 2, 2 and 2 is gone, is equal x. Okay? And let's see how much will be f composite with g of 2. So, which is equal x. So that means plugging 2 into x. So it's going to be equal 2, right? And the same way, g composite of with f of x. I mean, instead of x, I'll do 2. Is equal, again, here is this one, x, which is going to be equal, these two plugging here, it's going to be 2. Okay? All right. Now let's move to identify domain of composite function. Domain of composite function. So, what do we have? F of x is equal 2 over x plus 3. G of x is equal 1 over x. So, f composite with g of x, it's going to be equal, which means I'm plugging g into x right here. So it's going to be 2 over 1 over x plus 3. So we need to bring to common denominator here, this bottom. So what do? 1 over x plus 3, bring to common denominator. Common denominator is x, so divide by 3 times 3. And result is going to be here, x and 1 plus 3x, right? So if we divide 2 by 1 plus 3x, that will be 2 multiplied by x over 1 plus 3x, right? Because division by fraction, it's a multiplication by flipped fraction. So which is going to be equal 2 times x and 1 plus 3x. So what do we see here? So as a domain, x cannot be equal 0, right? Because of this x, correct? And x cannot be equal negative 1/3. Why? Because this is final answer, so 1 plus 3x cannot be equal 0. 3x cannot be equal negative 1. X cannot be equal negative 1 over 3. Right? Okay. Let me make it crystal clear. So we practically divide by 3, and that's how we got. Okay? All right. Next. One more example. So we have f of x is equal 4 over x plus 2, and g of x is equal 1 over x. Well, it looks like it's similar, huh? Yeah, it's similar. Let me pick up something more interesting, I would think. Okay. I can take this one. F of x is equal square root of x. And g of x is equal x minus 3. All right. So let's find f composite with g of x and find the domain. So what do we have to do? Obviously, x minus 3, plug into this square root of x, right? So f composite with g of x is equal square root x minus 3. And that's it. There is nothing much more we can do from here. And we practically arrived. And to find the domain, what do we have to do? X minus 3 has to be greater than 0, right? Because under square root, we cannot have negative number. And from here, x greater equal than positive 3. So from here, domain is going to be positive 3 and positive infinity. This is going to be our domain. Okay, well, that's all. And I see you in next recording.